on commercial planes, you might wonder why, when landing, it sounds like the engines are revving up with a lot of power. It may seem contradictory, but it's a system called thrust reverser, and it's the topic of this installment of the world of aviation. This is the moment when you hear the engines accelerating and the plane is clearly decelerating. There are three systems that reduce the speed of the plane on the runway. First, there are the wheel brakes, which work practically the same as those of a car, albeit on a different scale. Second, aerodynamic braking, using spoilers, for example. And the third is reverse thrust or thrust reversal. Let's see how this system mechanically works on a Boeing 777. And by the way, I introduce you to the new plane of the channel that will accompany us in several videos, and then we will see other forms of thrust reversal, as we had seen in the videos of how a plane flies and how a turbojet works. And if you didn't see it, I leave the cards at the top right of the screen for you to go and watch those videos. The plane propels itself by expelling a large amount of air backwards, generating a thrust forward. It's Newton's third law. So what I'm looking for to stop a plane is to direct that air forward, creating a thrust force contrary to the advance of the aircraft to stop it. And how is this achieved? Specifically this plane, but several share it in a similar way as follows. These gates close so that the air no longer passes backwards, but is reversed. They are usually operated by hydraulic or pneumatic actuators, or even electric motors with a worm screw. What you see here are deflectors, which are going to direct that air forward. These systems significantly reduce the speed of the plane, also reduce the effort of the landing gear brakes, and allow the plane to operate at airports with shorter runways, and in conditions of wet or icy runways, or these are essential. However, the rules dictate that a plane must be able to land on a runway without the use of these systems to be certified as operational black. Here Fabio shows us, in a real landing with a Boeing 737, how these systems are activated. And now, 2 reversals, normal 16-12 minutes now. We're going to get into the cockpit of our Boeing 777 to see how it's operated. First, the thrust reversal can't be selected until the engine control lever or throttles, which is this one, is at the lowest power or idle. You pull this other lever back to activate the reversal system, and until it's fully deployed, you can't give power to brake the aircraft. That's why it's pulled all the way back. When the mechanism is fully activated, there are two indicators in the pilot's cabin. In this case, because we have two engines, that will change from amber or orange to green. Depending on the model of the aircraft, thrust reversal can only be applied up to a certain speed so that the hot exhaust gases are not re-ingested by the engine, as they can damage it due to overheating or also damage it by the ingestion of gravel, dirt, sand or any other foreign particle that may be on the runway. In some airports, the use of these systems at maximum power is restricted due to noise or environmental restrictions. However, even in these airports, the pilot can activate it at maximum power if he considers it necessary in an emergency, for example. There are different types of thrust reversers, but they basically act in the same way, seeking to redirect the airflow forward like the one we had already seen, the one used in the Boeing 737. In the Boeing 737. In English, it is called blockers doors or blocking systems. In the Airbus A330, for example, companies can choose between three different engines: the General Electric CF6, the Pratt & Whitney 4000, and the Rolls-Royce Trent 700. The first two are similar to the systems we've already seen, but the Trent 700 opens 4 gates to reverse the thrust as seen in the photos. Another case are those that the legendary MD-80 and Boeing 727 had, as well as other executive planes. These, having the engines away from the runway, don't have to worry about damaging the turbine by ingesting foreign objects. These systems in English are called bucket doors or external doors. One of the main differences is that the latter uses all the hot exhaust from the turbojet. On the other hand, the one we saw before uses the force of the main fan or by diverting only cold air from it. But even though the hot air continues to exit towards the back, the force of the fan is greater and sufficient to stop the aircraft. Military aircraft also utilize these mechanisms, or freighters like the C-17 or the Ilyushin Il-76, and even fighter bombers like the Panavia Tornado, or the case of the systems, applications and products Vigans, which use another type of inverter, called clamshell doors, which even allow it to reverse. Thank you. I hope you liked it, but before I go, I would like to thank Pilot Dynam, Fernando from Commercial Aviation Costa Rica, and also Fabio. All of them provided me with images to use in this video. If you are also a spotter or have video material that you can lend me for my productions, I would also put the links so they can go see your work, and I would appreciate it very much. Until a new delivery, my name is Marcos, and this is World of Aviation. Thank you. Subtitled by Chen